Okay, I got some Berkner Beesies. Okay.
Where's Angela?
Or Tootsies.
Where's Angela?
I don't know. This is yesterday's. Oh, you were gone. Okay, yeah. Were you here the day before? It's that. No, I have tape. Did you get your worksheet, Angel?
Where are you, bro?
Wow. All right, here we go. Okay, ready. Part A. Okay, Jenny, read it aloud for us. These right here?
Fine.
The function is f is defined on the closed interval -5 and 4. The graph of f consists of 3 line segments and it is shown in the figure above. Let g be the function defined by g of x equals that.
Okay, good. So this is a graph of f. G is a function that's the integral of f. So part A, do it, and maybe you'll get a Berkner Beesie. Okay? Berkner Beesie. Okay, you should be able to do this ever since Monday. Part A. Okay, so what shapes are you shading? How many triangles? 2. And then when you find their area, are you going to add them or subtract them? Now, whoever said 3, you can do that as one big triangle. You can split it up into 2 little ones if you want.
But they cancel out.
One big triangle. Okay, now if you're going to cancel out, that's true, but here's the problem with canceling out. So in case you're confused about the beginning part here, so g of 3 is going to be the integral from -3 to 3, f of t dt, and then when I shade, -3 is here, but if I shade only to 3, think about what cancels out and what's left over. If I cancel this and this, then like that's not even really a thing anymore, right? Now you could break it up, but I just feel like is that really easier than just finding the triangles? Probably not. So I would probably not cancel those out. I'd just find top area and bottom area. Who has the top area?
10.
Good job, Berkner Beesie for Kane. 10?
What?
Did one of you say 10?
We both said it.
Oh, you didn't hear it.
Speak up next time,
Steven, you know you've taken all my Berkner Beesies so far. Okay, so this one's 10.
Speak up next time, bro.
Okay, what about the little one, Angel?
What's this?
Maybe if you'd been on time, I would have heard you. I don't know. Okay, it's 1, and then I subtract. So 10 minus 1 is 9. Good. Okay, part B.
Oh, you can't have one.
Okay, focus. Okay, part B, I want to know where G is increasing and concave down. This is where you have to stop, find G prime, find G double prime. So increasing, I want G prime of X to be positive. Concave down, I want G double prime to be negative. The problem is we don't know what those are because they only gave us G. So if G of X is the integral from -3 to x f of t, what is G prime? F of x. Good job, Glenn. Okay, and f of x in the graph is going to be the y value. What will G double prime be? F prime, which is the slope. So look at your graph. I want G prime to be positive. Where will F be positive? Tell me what you're looking for. Yeah, above the x-axis, yeah. And then I want a negative G double prime, then I need a negative slope. But remember that I need both of those to be true at the same time. So it's like I can find one or find the other, but I really need both. So when am I above the x-axis and I have a negative slope? Yeah. and there. Good job. Those two pieces. Okay, so for part B, I'm going to write my explanation down here at the bottom. Okay, I would say from -5 to -3, union. Then I would say from 0 until 2, because. Now, all of this stuff over here is kind of scratch work. When you're giving a reason, it needs to be like a real sentence, like an explanation. So, because g prime of x, which is really f of x, is greater than 0. And what else were we looking for? G double prime, which is equal to, which is the slope of f is less than 0. Okay, and remember, both of those things have to be true. Okay, you need a positive y value and then a negative slope. Good? All right, part C. Okay, this has kind of nothing to do with fundamental theorem, but we're going to do it anyway. So, function h is defined by h of x equals this. We want h prime of 3. What are we going to do first? Is that a thing? How do you take the derivative of a fraction? Quotient rule. Remember, Hody High? Okay, so this is kind of throwback. Okay, but we need quotient rule. So remember, high is what's on top. What's on top? Okay, ho is what's on bottom. Okay, then remember, d high and d ho are the derivatives of those. So the derivative of g of x on top is g prime of x. Derivative of 5x on the bottom is just a 5. And then remember your quotient rule, which side goes first? Hody high, very good. So h prime of x equals 5x g prime of x minus, and then Heidi ho's the other diagonal, g of x times 5. Over what? Is this right?
No.
Why? Yeah, so you can either put 25x squared, or you can do 5x squared. But you have to do one or the other, or it's wrong. Okay? So that's h prime anywhere. Where do I want h prime at? 3. So h prime of 3 is going to be 5 times 3. What's that? And then I want g prime of 3. I'll come back to that in a second. Minus 5 times g of 3. And then 3 plugged in here, 5 times 3 is 15. You may know the square of 15. If you don't, though, it doesn't matter. Okay, you don't have to do it. Now, once I get this down to something that can be typed into the calculator, that's when you're done. So, can I type g prime of 3 in the calculator? No, then I need to find what it is. So, come back up to the top. What did we say g prime is the same as? F. So if I want g prime of 3, I really want f of 3. What's f of 3? Okay, 1, 2, 3. Right there, it's -2. So this is going to be -2 in that spot. Oh, thank you. And then what is g of 3? How did you know it was 9? We did it in part A. So remember, I don't want to go back and refine stuff. I already know what g of 3 is. G of 3 is 9. Okay? And so then from there, I'm just going to write it out like that, and then I'm going to leave it. So 15 times -2 minus 5 times 9, 15 squared. That's my answer. You can work it down further than that, but if you make a mistake, you'll lose the point that you would have gotten if you just left it. Okay? Now, D is a great question, but we're going to skip it, okay, because it doesn't really have anything to do with what we're doing, and we need to get to chain rule. But part E, we're going to do. So, it says, capital F is the antiderivative of little f. We already knew that. Okay, it is given that f of -3 is 2. This is what we have. And we want to find f of 4. This is what we want. So I'm going to remind you how to set this one up from yesterday, and then you'll do the second one. So the first thing I would say is, okay, my graph is of little f. So I'm going to integrate from what I have, which is -3, to what I want, which is 4. What is the integral of little f called, we said? Big F at 4 minus big F at negative 3, right? And then remember, version B of fundamental theorem is just when I take this number and I just, add it to the other side. So I'm going to say, okay, well, if I want f of 4, this is what I'm trying to find, then I'm just going to add f of negative 3 across, and then f of 4 is by itself. Remember, that's called version B. So f of 4 equals f of negative 3 plus the integral negative 3 to 4. And then what did they tell me f of negative 3 is? They gave it to me in part E. 2. And then this integral, how am I going to find it? Using area, right? So come back up to your little graph. Let's figure this guy out, and then we're done with that part. I'm integrating from negative 3 until 4. So I need to expand this little triangle that used to be just a 1. Now it's that full piece right there. So it'd be 1/2 base times height. 2 times 4 is 8. Half of that is 4. So 10 minus 4, my leftover is 6. And then what's 2 plus 6? 8. Make sense? Okay, now you are going to find f of negative 5. Okay, you are going to find f of negative 5.
So we just found f of negative 3 or f of 4? F of 4?
Yeah, so I would still use f of negative 3 as you're given. Here's why. I found f of 4, but what if I found it wrong? Right? Then I'm using a wrong answer again. So I would let your other number still be f of negative 3. So it's going to be what I want, which is, It is going to come out backwards, yes. So here's the way that I'm usually going to say this. What I want is what I have plus the integral from what I have to what I want. Okay, what I want, f of 4, is what I already have, f of negative 3, plus the integral between them. So if I want f of negative 5, what do I have? F of negative 3 plus the integral from what I have, negative 3, to negative 5. Okay, the other thing I want to remind you of is that whatever's in here, okay, should always be 1 less than that. So if this is the antiderivative, I did capital F, that's what you want. Okay, then from here, what's f of negative 3? 2. And then find that second integral, please. Okay, why is it negative if the area is above? It's reversed. Good job. Okay, that is backwards. So if you find the area on the graph, it's 2, but I have to count it as a negative 2, so it comes out to be 0. Got it? Yeah, because it's 2 times 2, and then half of that. You're going from negative 3 to negative 5.
Yeah, but it's 1/2 base, and that's 3 times.
No. It's 1, 2. You're counting the lines, I bet. Remember, it's 2 here, and then 2 here. Yeah?
Oh, Jesus Christ.
Good? Okay, you ready to do chain rule? You love it? Yes. Okay, take a look at your notes. Okay, I will not make you discover the chain rule. Okay, like I made you discover the second fundamental theorem. But here's what it is. If I take the derivative of an integral from a to u f of t dt. Okay, how do you do chain rule? You still keep the middle a u, so it's going to be f of u, but then you have to multiply by the derivative of the middle. If it's a u, what am I multiplying by? U prime. Good job. Okay? So this should not be a much harder version of what we already did. Yes? No, this is a U. Thank you for asking. Okay, now let's talk about what A and U are. So A is going to be a constant. And then U is going to be an expression of X. Okay? So for example here, pi sixth, what's that? A constant. What is 6x? It's an expression with x in it. Okay, same thing here. It's not just an x, it's a 9x squared. But the bottom has to still be a constant. Okay? So let's do number 1. Easy, easy. You're going to take the u, you're going to plug it in. So I'm going to take the 6x, I'm going to plug it in. Now it's what? Secant 6x. But then I have to times by u prime, and u is a 6x. What's the derivative of that? Times 6. Now remember, you can put it at the back or you can put it at the front. It doesn't matter. It just has to go somewhere. Okay, easy? Okay, next one. Integral from 1 to 9x squared. We're taking the derivative, so I circle the 9x squared. Plug it in where the t is. So I have square root 9x squared plugs in. And then what do I need to multiply by in the front? 18x. Because remember, you're taking the derivative. So the 2 will times down, and that's where the 18 comes from. Okay, last one like that. Number 3, what's wrong with it? Okay, it's backwards, so if I reverse it, what do I change? Yeah, just change the sign. So it should be a minus 4 cosine 3t. And then once I reverse it and take the derivative, I sub the 2x in. Remember, there was already a 3 in there, though, so what's that going to be? Okay, 6x, and then what do I have to multiply by in the front? A 2. Now, why am I not multiplying by a 3? That's not u. Where was u? At the top. This is u. So u prime is the derivative of the end point that you just subbed in. Does that make sense? So I'm going to multiply by 2. Negative 4 times 2 gives me negative 8. Make sense? Okay. Alright, we're going to skip part A in the interest of time, go to part B. So f is this function. Notice it has an integral in it. What do I do when I need f prime? I take the derivative. When I take the derivative, d dx, of the integral from 1 to 2x, what do I do? Oops, that should be a t. You use the second fundamental theorem of calculus. So if I take the derivative of this function, I circle my 2x, plug it in, and then what do I have to multiply by? 2. So it'll be 6 2x minus 1 squared times 2. Which means I could rewrite that how? Yeah, 12. And then the 2x minus 1 squared. But does that make sense what's happening? Because the derivative and the antiderivative undo each other. You're just switching out the letter. Okay, then in part C, what would I do for f prime of 2? Yeah, just take the 2, sub it in. 2 times 2 is 4. What's 4 minus 1? So that's a 3 squared. 3 squared is 9. 12 times 9. I'm just going to leave it like that. Good? What about if I want f double prime? What am I going to do to this now? Take the derivative. And what rule is that going to need? Product, quotient, or chain? Okay, chain is correct. Okay, good job. So my 2 is going to come down on the 12. What's 2 times 12? 24. And then my 2x minus 1 used to be squared, but I have to take it down a notch, so now it's to the power of 1. But then chain rule, I have to times by the derivative of the middle, which is another 2. And then the 2 and the 24 can multiply to be a 48. And then a 2x minus 1. You can leave the 1 up there if you want to, but you don't have to. Make sense? A little bit. Okay, then part E, what would you do? Just plug in 1. So 2 times 1 is 2 minus 1 is 1. 48 times 1 is 48. Okay, I'm going to give you 2 to try off your homework. Ready? So homework 11, I want you to try number 3 and number 7. 3 and 7. Off of homework 11. Good question. So we're probably not going to finish all your notes today, so your quiz will be on Monday. Your homework will be due Monday as well. So we'll finish up notes and stuff tomorrow. If you have questions on the homework, we'll hopefully have a little bit of time, and then we'll do your quiz on Monday.
Which numbers?
3 and 7. Where's my tape right there?
What's that?
Okay, number 3. What should you get?
What's up, dog?
Okay, plug it in. What do you get for number 3? Okay, 1 plus 4x squared and then times 4. Easy, right? Okay, go down to number 7. Okay, part A, I want to take f prime of x, but f has an integral in it. So f prime, I take the 2x, plug it in. What do I get there now? Sine of 4x times 2. Very good. And you have to remember that your u is this. So 2x, I put it times 2. Okay, then skip down to here. I want the second derivative. What's the derivative of 2 sine 4x? Cosine 4x times what? What's the u though now? 4, and I already had a 2, so what's in the front now? An 8. When I plugged the 2x in, next to the 2 already in the middle, that's where I got the 4 from. Make sense? Then you're plugging in pi 8ths, then you're plugging in 0. When I plug in pi 8ths, careful on that one. Okay, pi 8ths is not a reference angle. But when I plug it in, what is 4 times pi 8ths the same as? That's really pi halves, and that's a reference angle. What is the sine of pi halves? 1. So it'd be 2 times 1, which is 2. Okay, next one I'm going to plug in a 0. 8 of cosine 4 times 0. Well, what's 4 times 0? What's cosine 0? So 8 times 1 is 8. Got it? Easy? A little bit? You love it? Okay, now go back to your notes and turn the page. We have just a couple of our cues, yes? Correct, because remember, it's an integrals derivative. So you're doing a derivative and an antiderivative. That's why the function here stays the same. It's because if I take the antiderivative, but then I take the derivative, I would have gone up to cosine and then back down to sine. If you think about like the snow cone thing, it's like you're going up, but then right back down. Okay? Alright, so we're on our notes. We're ready to do how many FRQs? Okay, at least 1, maybe 2 FRQs, we'll see. Okay, so take a look at number 1. G of x is here. I want G of 1. What are we going to do? This is off your notes. The notes for today. So how will we find G of 1? What did we do before? We're just going to plug the 1 in where the x is. So I'm going to have the integral from 0 to what? 2 times 1 is really a 2. of f of t dt. So even though this is a 1 here, I'm plugging a 1 into the 2x. That gives me a 2. And then in the graph, you're doing the same thing. So 0 to 2, what's my shape? Triangle. Area of the triangle, 1/2 base times height. 2. And it's above, it's not backwards, so I don't have to turn anything negative. Okay, second part, I want g prime of 1. Then I want g double prime of 1. Now, we have to be careful here. If my g of x, I'm going to write this up here at the top, is the integral from 0 to 2x f of t dt, what will g prime be? F of 2x times 2. And if I take the derivative of that again to go ahead and find my g prime, what's the derivative of f of 2x? F prime of 2x times another 2, which turns that into a 4. Does that make sense? Okay, so g prime of 1 is going to be this right here. It'll be 2 times f of 2 times 1, which is really what in the middle? F of 2. And then what's f of 2 in the graph? F would be a y value. Y value would be 0. So 2 times 0 would be 0. Next I want g double prime. Now when I'm looking at the graph, what happens at 1?
It's a corner.
It's a corner, but is this going to come out to be DNE?
Oh, because it's
No.
a slope.
Because when I plug in 1, I'm plugging it into the middle. Where am I really going to be looking at the graph at? 2. Does that make sense? So even though there's a corner here, it doesn't matter because I'm not really going to be looking at 1. When I plug my 1 into my 2x, really I'm going to be checking the slope of the graph at 2. Does that make sense? Okay, so I'm not going to write this as 2 times 1, but that's where it's coming from. Okay? And then what was the slope here? Down 2 over 1, so it'd be negative 2 times 4, which is negative 8. Okay, do part B. Okay, very similar. Did you say I hate this? Oh.
No, I didn't.
What was that? You love this? This is your favorite?
Trash about math.
I'm not that intimidated.
You're not tempted? Okay, we're working through your second page. We're looking at the FRQs. Anybody get g of negative 2? Oh, or should you have to shade between the x-axis?
Yeah. Because it has to be between the function and x. I don't know. Let's find out. Okay, where should my integral be from? 0 to negative 4 f of t dt. Okay, and then technically, if I'm going 0 to negative 4, I really have to have 2 separate shapes. Okay, I have a trapezoid there, and then I have a triangle next to it. Okay, let's do the trapezoid first. So it'll be 1/2, base 1 is 2, base 2 is 3. So it'll be 1/2, 2 plus 3, and then my width is this way, it's another 3. So that'd be 15 over 2, which is 7.5. Okay, then let's do purple. We'll have 1/2 base times height. My base is a 1, my height is a 2. 1 times 2 is 2, half of that is 1. So if this is 7.5 and this is 1, they're both negative, so what should my total integral be? Okay, now question, is the negative correct? Oh, okay, even though the area is below, it's also backwards. Okay, negative 4 should have been on the bottom of this guy, so I need to switch that back to a positive. So I'm going to put it's positive because it's backwards and below. Okay, and if it's negative twice, then really we know it's just positive. Okay, next I want G prime. G prime of negative 2, I plug my negative 2 in here. Then I want 2 times what? F of what? Negative 4. And then look at your graph at negative 4, what's the y value? Negative 3 times 2 is... Okay, next one, G double prime. 4 times F prime at negative 2 plugged into 2x is still a negative 4. But this time I'm going to be looking at what in the graph? The slope. So I'm looking at this little line segment, count from the pretty points. So I count up 1 over 3, so it's a third. Yeah? So then I'd have 4 times a third is 4/3. Make sense? Okay, it's going to get a little bit worse before it gets better. Okay? A little bit worse. Okay, so next question, where are your critical numbers? Put dots on the critical numbers. How many are there? 2. So I have 1 here, and I have 1 here. Are we all good with that? Okay, what type is 0? Min, and then 2 is a max. Okay, now, here's the problem. Okay, so I have a max here. I have a min here. Okay, for 0, it ends up not mattering. So I'm going to go ahead and write it out. X equals 0. It's a relative min because G prime of x, which is 2f of 2x, changes plus to minus. Okay, that looks almost like it's perfectly scripted from the last notes. The only difference is I have a 2 here. Now think about it. If I multiply a positive by 2, is it still positive? Yes. What about if I multiply a negative by 2?
I think you meant negative. Yeah.
I did mean negative to positive. Thank you. Okay, but, okay, the 2x in the middle matters. If I plug in a 0 to a 2x, does it stay a 0? Yes. Okay, for the 2, that's a problem. If I pick x, everybody listen at the same time. I'll say it like 2 or 3 times, and then hopefully you'll get it. Okay, where do I want the sign change to happen at? 2. If I pick 2 and I plug it in here, where would I be looking at on the graph? Is this sign change at 4? Then I can't pick 2. What x should I choose? Okay, good. What x should I choose to plug in here so that this comes out to a 2? Okay, one more time. I need an x that will make this be a 2. So I have to choose 1. Does that make sense? Okay. So now the easier way I think to think about it is if there's a times 2 in the middle, whatever number I want, I'm just going to divide the 2 out. Right? Does that make sense? So you're just kind of like undoing the 2 with the x. So I'm going to put x equals 1 is my relative max. And that is because G prime of x, which is double f of 2x, changes plus to minus. But remember that I chose the number 1 because when I plug it into 2x, it gives me the right spot on the graph. Okay, now we're going to do the same for points of inflection. So mark your points of inflection with an x. Points of inflection should be anywhere the slope changes sign. Where does the slope change sign? Okay, at 1. So come out to your graph. I have a slope change here at 1. If I pick 1 as my x value, though, and I plug it in here, what's 2 times 1? Not a 1 anymore. So what x do I pick so that the whole thing comes out to a 1? A half. Does that make sense? There's an extra times 2, so I take what I want and I divide it by 2 to undo that. I pick a half. Does that make sense? Okay. So we're putting x equals a half. I do not remember if the quiz is a chain rule or not. Now the other thing I'll add while we're covering this is usually they don't pick a chain rule if they're going to do a free response on it. They've done 2 chain rules out of like 20 that weren't chain rules. But if I never showed it to you, right, then you'd be screwed if you had it on there, right? So we have to kind of cover both, but keep in mind usually they're not doing chain rules on these. So x equals a half because g double prime of x, which is 4f prime of 2x, changes sign. Does it matter which way it changes sign for a POI? No. Oh, we should do that. Thank you. Which is slope of graph f. Thank you. Okay. Now the other thing I'll say too is a lot of years if you didn't put this you might have been fine. But other years you wouldn't be fine. So that's where you just want to be as extra as possible so that they can't take off points. Okay, part F, I want average rate of change. What's that? Yay, AROC. How do I do AROC? Yes. G of 1 minus G of negative 2 over. Good. Okay, I already found one of those. Or actually, I found both of those. What was G of 1 in part A? 2. What was G of negative 2 in part B? 8.5 over 3. Answer. Okay, leave it. Doesn't matter. Okay, last part. This should look to you like a version B. Here's how you know. What do I have a graph of? Little f. What do I want? Big F. That's version B. Now, what did they give me? So, that's my have. That means that I want f of 1. So remember, it's what you want equals what you have plus what you have to what you want. Okay? Okay, it's what you want, f of 1, that's what I'm trying to find, is what I was given, f of negative 1, plus the integral from what I already knew to what I want to know. So, want equals half plus integral have to want. Yeah?
Yeah, sure.
Okay, what's f of 1? That's what we're trying to find. What's f of negative 1? They gave it to you, it's 3. Plus, and then how am I going to work that integral? Look at the area on the graph, yeah. Negative 1 to 1, though, what is it? This should be easy. Oh, what? 0. Why is it 0? Yeah, look. You end up with negative 1 to 1 is that. Gone, dead, nobody left, no survivors, so it's 0. So it'd be 3 plus 0, which is 3. Okay, now you do it for f of negative 4. Okay? So it asked you to find 2. It asked you to find f of 1. We did it. So now do f of negative 4. Okay, so what I have is still f of negative 1. What I have is negative 1 on bottom to what I want is negative 4 on top. What's f of negative 1? 3. And then if I integrate negative 1 to negative 4, I need to do area on that. Negative 1 to negative 4 was my trapezoid. We already did it earlier. How big was it? So it'd be 3 minus 7.5. Y plus. Because it's below, but it's also backwards. Okay, so that's really a plus, so it'd be 10.5. Good? You love it? Okay, we don't have time to do the next one all the way through, but turn to the back page. Okay, we're not going to do all of this. We're just going to do the first part. Okay. A and B. Okay, let's do these guys right here. So part A, I want F prime. Here's F. Right away, easiest AP question ever. Okay, here's F. I want the derivative. What do I do when I take the derivative of a function that's an integral? Plug the 3x in and then... Okay, good. So F prime of x is 4 plus. My t is now a 3x, and then I times by 3. Good? Okay, what about g prime of x? Okay, well, here's g. How do I take the derivative of g? Wow. Okay, good. The outside function is x, so the derivative of f is f prime. Sine x stays the same, but then I multiply by the derivative of the core at the back. That's your chain rule. So if this is a sine x, the derivative of that is cosine x. Now, okay, here's the problem. If this was the real AP test, you could not leave it like this because f prime is not x. But what do I know f prime is? This, right? So all that I'm going to do is I'm going to say, okay, well, if I want f prime of sine x, I'm just going to put that here. And then it'll be written in terms of x, okay? So g prime is really, we're taking sine x, we're plugging it in here. 3 root 4 plus 3 sine x squared cosine x. Yes. Okay, but do you see the difference? This is in terms of x. This is in terms of f and x. And that's not what it said. Okay. Then part B, I want a we'll just stop there. Okay? Because it's already 48. So tomorrow we'll do one more FRQ. Make sure your homework's mostly done. If you have questions, we can go over it. And then your quiz will be on Monday. Homework's due on Monday as well.
Those notes.
Angel. Are you listening to Papa Smoke? Yes.
The difference between today and yesterday was the derivative.
Yes. Yesterday, this x was always a 1.
Oh, yeah.
So what makes it chain rule is that if there's a number up here, you have to, like, undo the fact that that number's there when you do these down here. Does that make sense? So let me give you a different one, okay? Let's say this is a graph of f prime, this is 8. Normally, I would say, and let's say that your integral is from 0 to 2x. Okay, so I know this is the max, but I need it to be for a 2x. So what x would I pick for it to come out to be 8? 4. That's right. What if this was a negative 10? Just pretend. If I want 2x to be negative 10, then I need x to be negative 5. Does that make sense? So it's still changing sign in the same way that this would be a min and this would be a max. What's changing is that I have to undo it when I list my POIs and my mins and maxes. Now, let's say that you were asked to find g of 3. Well, then I'd really be doing the integral from 0 to 2 times 3, which would be 0 till... Yeah. So when you're doing the integral, you're still just kind of plugging it in, doing the area. But this number is not going to match what's on top if it's not just an x.
Okay, that makes sense.
And then were you here when we started these? Yes.
Did you take a 10?
I didn't mark you up, so.
Okay, thank you. Okay.
And then we did, you were here when we did the examples off the homework, right?
Yes.
Okay, and then let me write here the derivative. I think this is right as you were coming in. Bye, see you tomorrow. So the u plugs in, it'd be f of u, and then just times u prime.
Okay, I got that part.
So like here, you take the 6x, plug it in, it'd be secant 6x, but then times by what? 6. Times by 6. That one, you take the 2x, plug it in, and then times by 2 in the front.
Okay, that makes sense. Okay.
No.
Can I please get a pass? Because I need to make a stop at the restaurant.
Yes, that's fine.
Thank you.
2-20-20.
Is there a pocket outside?
Yeah.
Why is that?
I don't care how I look no more.
Thank you.
I don't care how I look no more.
Why? You're done making TikToks?
Nah, I'm still trying. Nah, I haven't made TikTok. But TikTok's not even funny no more.
Why?
See, there's love up.
You gave your life to TikTok, and what has it done for you? Here you go.
Spent hours on TikTok.
It's a pass.
Can I have a pass?
Why
I
you
even
learn
asked
from
me.
it?
For what?
Exactly. You know I don't need passes.
Oh.
Can I have the keys?
No. I'll give you a Tootsie Roll.
Yeah.
Kane.
There you go.
The first day of school, they gave me their names backwards, and I was confused.
No, I did it to Mr. Boo. That's your bad. I made him for 2 weeks.
Oh, little Mr. Boo,
No,
you
don't say little.
bullied
You
him.
didn't like me.
I remember Jim when he came up to us, he was like, hey, you know what's wrong with doing it like that?
I told him my name is Jeremy for 2 weeks.
You told Mr. Boo?
Oh, yeah.
How did he mark you present?
I would say, here's the Jeremy. You would say, here for
You
me.
can only have a Tootsie Roll.
Right. We went in a fight. You were,
I get it. Yes, I will.
No. I have to get rid of these so I can buy more candy.
Ooh, I was gonna jug. You saw that?
Ooh, I'm fixing to jug you.
I'm gonna turn in all my homework.
What does it mean if you
I'm
jug
gonna turn in
stuff?
all my homework. So
Okay,
6,
so
7, 8, 9, 10. No, all my homework. I need to do my test and I put it on.
yeah, well, where you been? You haven't been correcting the test for like 3 weeks now. You have to do both of them for me to grade them. Now, if you're not going to come in and do the second one, remember, you get the corrections in the corrections category. But yes, it's the equivalent of that.
What does he have here? You know what you did.
I know. He's getting so much. He's probably going to have to fill it with no, bakery. Oh, I meant to, yeah. Where was he today? That doesn't mean you're told to put a glass. Alright, see y'all. I've been good. I always